All right, let's get back. I know it's getting a little bit tired. So for every location that we have to find out how many peak hours we have over a period of a day. So therefore, that would give us the amount of power that we can have during the day to be able to do our calculations. And you know, every day is different. So therefore, statistical data has been obtained for a whole period of time, different types of seasons and so forth. It's been tabulated, and it's been easy for you guys to obtain. So typically by the middle towards the end of the class, we find out you select, as a matter of fact, you select a certain location, you plug in the number, you put actually, the way it's done is actually through a computer program. You put the zip code of the area that you have, and it's automatically, they give you a whole printout. I'm going to give you that, yes. I'm going to give you that as well. I'm going to give you also a test. So actually, as we go through the course, as we'll go through a lot of this next chapters, every so often I'm going to ask a question. Do you remember this? Do you remember this from the previous classes? So forth. All right, but some of you are sort of a little bit fidgety up there and says, let's get into it, let's get into it, let's get into it. We're going slowly because eventually if we just jump into it and then we have to fall back of it, it'd be more difficult. That's why we structure the course in a way. I mean, some of you, obviously, it's going to be a little bit boring now. It becomes a little bit more interesting later. Some of you find the interest now. Some of you find it boring totally. What we're going to do, we try to help everybody as we can. But a lot of this stuff is important. The actually mechanical part of it, later on, it'll be much easier. Extremely easy. So you put location, for example, Edison, New Jersey. You plug in the zip code out of it, and you'll know exactly how many peak hours you have for a particular season. You push the button, and you have a graph for it. So now you take that, and you submit it down as part of your documentation, whether you submit it with the inspector and so forth. I will be able later on actually to, as we go through, to show you just a simple little design somebody did, some an average electrician did by himself by utilizing that. And I will show also a design that it was done by an engineering firm with all the bells and whistles and so forth that is required. Both of them, they were reviewed and they were actually approved. One is smaller than the other, much smaller than the other, but all of them had the information that it was required for them. Because talking some of the outside, and the outside with the guys, a lot of you ask, what do I have to do? What do I have to do, you know, to install? All of you are a little bit concerned about the permitting considerations that takes place in order to be able to install those systems. And you should. Okay? Now, so we said what peak sun hours is. Now, insolation. Now, this is the word that you're going to hear most of the time. Sometimes you're going to hear solar radiation, but the name is going to be usually insolation. Insolation is nothing more than solar radiation. Okay? It's just another term they use. As a matter of fact, most of the times manufacturers utilizing this word insolation. So just another term. The energy that reaches the Earth's surface over what? The course of the day. That's it. Okay. Usually, it is very similar to radiation, but it's expressed in what? Kilowatt hours square meter per day. This is the number that you will need in order to be able to do the calculations, the analysis that is required for you to design the system. Okay. So you see a particular location says, what is the insulation about this? This is the amount, the number that you're going to get from the Now, what happens is they took this data and they made what's called a map. And they have maps of this all over the United States and all over the world, actually. So you can see for every state in here, and they made them in colors so this way you can differentiate from it. And you can look at these colors in here, and you can see certain areas. So you can see in New Jersey, for example, the coloring is here is what? Well, depending on the area, you can see it's between what? 3.5 to 4 peak sun hours per day. So in New Jersey, or if we look at the top version in here, you can have what? Between 3 to 3.5. So depending on the site that you have in here, in New Jersey, you have a certain amount of what? Of peak sun hours. Is that good or bad? Well, in comparison to where? And here, we put bad, but we're still getting a certain amount of what? Sun hours. Is that clear? Now, this data here, it's been taken, it's been tabulated, it's been tabulated out with all the parameters that it's available to you. So if you take up a certain town location in here, you can pretty much find out exactly the amount of sun hours that you do that. Okay.
That's peak sun hours at a certain angle, right?
No. This is the average numbers of peak sun hours, assuming that you get 1,000 watts per square meter insolation. Remember, over the period of a day, the amount of what solar radiation that varies. Okay, it varies. Okay, so what do? You take that number, you compile it, you divide it by 1,000 because that is what the reference point we have, and then we're coming out how many what hours per day. How many peak hours that I have. A peak hour is considered what? 1,000 watts per square meter.
And that has nothing to do with if you're looking this way, if you're looking this way, if you're looking that way.
The reference point is that you're getting 1,000 what? Watts per meter square. If I have a plane in here, and I get 1,000 watts per square. It's an average insulation. Yes.
You normally want to focus your panels toward the south.
Yes. We'll talk about that a little bit later on. Because what happens is you could at every point in time, and actually the graph that you would get, actually there's data that it can tell you how much you get for every possible location, at every possible location. Actually, you're going to get this for that particular location that you have. Excuse me?
That would be with the meter sitting on the ground, just open to like all angles.
Yes. You would be that data. It's actually tabulated. It's been taken and it's been tabulated for you because they have taken data from the 1960s, I think, or up to 1991. Because that you want to make sure, in order to come up with a number, to take enough data and tabulate and make sure deviations of weather conditions and stuff like that to come up with the average. So the average for the New Jersey is between 3 and 3.5 hours of peak sun radiation. You have to understand in calculus you have to establish some reference point. So actually the number cannot be 3.555 for every location. However, as data becomes available now, you can say Edison, New Jersey gets 3.5 hours, and then we can, for every period of time, you can actually tell you exactly how much you get per hour per day for whatever location, and you can get them in tilt angles and everything you want. All this data is tabulated. From an engineering design point of view, you may want to have that. From the practical design that you would do, the average number is sufficient enough. Remember, from our point of view, you don't want to make the design of a solar system, a $10,000 job. You want to make it a simple job. It's the same thing. You want to be also correct. There's a lot of factors that actually contribute to the performance of the solar system that you design, photovoltaic system, and that.